So today, guys, we are looking at elements. Elements is a very common topic. Elements. So if someone asks you, what is an element? What response do you give them? What is an element? Anyone? Anyone? What is an element? Tamda ibusho Maria skam grade 12. Nishi Maria mukchidinga. Yes, Samson. Samson.
An element is a yes, I'm certain. An element is a fundamental substance that cannot be broken down by any chemical means into simpler substances.
It's a fundamental substance which cannot be broken down by chemical means into simpler substances. So now, just like the word
by any
or by any chemical means, you have already said the answer. It's very correct word. So I'm trying to explain that just like the English alphabet, all words come from the alphabet. So now, all substances in the universe also come from elements. So there is no fixed number of how many elements there are in the world because we are on Earth and there are different places of the universe that we've never been to. So when there's a discovery made of an element, they update. The last update they made was 2011 when it was stated that of recent, the number of elements in the world is 118. So you remember when we were doing classification of matter, we said matter can either be a pure substance or a mixture. So pure substances are the ones we classified as elements or compounds. So now the difference is that for the compound, you can break it down. Meaning if you have water, you can do a chemical reaction and actually get hydrogen and oxygen. Then if you have copper sulfide, you can break it down into copper and sulfur. So those are the things. Compounds are substances, pure substances also, which can be broken down by chemical means. But elements are pure substances which cannot be broken down by chemical means. So they are fundamental because they are the reason why there is chemistry, meaning without elements, you cannot have a compound. So that's the aspect. So now, the idea is that these elements are numbered in order of increasing complexity. So what we mean is from simple to complex. And what do we mean by simple? We mean the lightest element is the one that is named first. Lightest meaning the one that has the smallest mass. So the smallest mass of element is hydrogen. It has atomic number 1. So I'm sure you know about hydrogen. So that is it. You start with hydrogen, you go to helium, you go to lithium, and so on and so forth. So your job is not to really go in the periodic table and try to understand all of it. You waste your bundles. Maybe if you're doing it for a quiz, sure. But for us, periodic tables are given all the time. If the periodic table is not given, the information required, if it's supposed to come from the periodic table, must also be available to you. So that is the aspect. So you must understand that. So the other point is that 88 elements are known to occur in nature. What do we mean by known to occur in nature? Meaning you can encounter them. You can encounter them in nature to say, here it is, here it is. Others are made in the lab. Other elements are made in the lab, or they are not in this part of the universe. Then there are also those that come from radioactivity. So you have 88, which are known to occur in nature. Then after that, you will find that below 88, there are 4 which are or that have transitory existences. 4 have transitory existences, meaning for them to occur, it's a radioactive decay. I'm sure you did those decay equations. So something is decaying, it actually becomes that element, and then you get something else in the end, meaning they don't actually occur in nature. So of those, so we have technetium, promethium, astatine, and francium. Don't worry about these things, they're in your notes. Technetium, promethium, astatine, and francium. So those are the things. Then the other ones above the above 92, most of the elements do not occur in nature. Most of them have just been synthesized. People have been looking for Nobel Prizes, so maybe the discovery is a new element. So the most important point that I'm driving to now is that you should say an element contains the same type of atoms. What do you mean by same types of atoms? Atoms that have the same atomic numbers or proton numbers. So elements have identical atoms. So the representative of the element, so if you give that answer, guys, to say what is an element, instead of what you said, cannot be broken down. If you say an element is a substance that has identical atoms with the same atomic number or proton number, the marker should give you the maximum points, because so the representative of the element everywhere in our equations is the atom. So try to understand it from that perspective. Are there any questions at the moment? Are there any questions at the moment? If there are no questions, we would ask, what is the atom? Yes, sir? Crispin? Yes, Crispin?
Yes, sir. I just wanted to confirm. You said an element, if you give a definition of an element, is a substance that contains the same atomic number and proton number.
The same types of atoms.
Or the same types of atoms.
The same types of atoms. Or an element is a substance that contains identical atoms.
Okay. So now, where, like, how do you differentiate that from a molecule?
I was expecting you to say, how do you differentiate that from isotopes? Because a molecule is the simplest of the compound. If you have your water, H2O, the H, if you have hydrogen alone and two hydrogens and 1 oxygen, all of that combined, bonded together, that is your molecule of water. So the simplest of a compound is a molecule. The simplest of the element is the atom. That is the difference. But when you are defining isotopes, we go further, because isotopes are atoms of the same element. So meaning the element contains isotopes. The element contains the isotopes. So I was expecting you to talk about isotopes and not molecule, because molecule is the simplest of the compound, or it's the simplest substance that exists independently, because we leave it open like that because there are some elements in nature that occur combined. So that's the reason why. But the simplest, if you have a formula unit of water, H2O, that is a molecule for you. Are we there, Crispin?
Yes, sir.
Yes.
Yeah, I'm
All
getting.
right. Okay. I was expecting someone to define the atom for us. Guys, atom. What is the atom? Patience. Patience.
So an atom can be defined as the smallest particle of a chemical element that can exist.
An atom is the smallest particle of the element that can exist. That can exist. Patience.
Oh yes, sir.
Exist, that's all. I'm expecting, I want more. I want more.
Wechapwa.
Who has something you can add to Crispin?
Okay, let me just add a little bit. It says an element is the smallest particle of an
An
element
atom
that
is
can
the
take
smallest
place in chemical
yes.
reaction.
An atom is the smallest particle
Of an element that can
yes,
take part in a chemical reaction.
that can enter a chemical reaction. So the smallest the element can be is the atom. Meaning the atom, groups of atoms, identical atoms, we said, make an element. So the smallest part that can actually react the same way the element is expected to react is the atom. So this atom also has subatomic particles. It also has subatomic particles. I'm sure you know them. So the subatomic particles are the protons, the neutrons, electrons. Those ones, the subatomic particles, guys, those ones are different from the atom. They, like all of them, electrons in nature are the same. Protons in nature are the same. You cannot tell to say this proton is from this element or from this element. So those ones, they are not characteristic of the atom. They don't even enter chemical reactions. So that is an aspect. So one thing that we've learned is that elements contain identical atoms. They are pure substances. 88 are known to occur in nature. There are just 4 there that have transitory existences during radioactive decay. You read it in your notes. Then the other point that we've said is we've also defined the atom and said the atom is the simplest element you can have. The atom is the smallest part of the elements that can enter a chemical reaction. So that is the case. So the next thing is you have to know about the distribution of elements. Distribution of elements. So what we say is that the first thing is elements are known to occur unequally in nature. Just like wealth, elements are known to occur unequally in nature. So meaning you don't have equal elements like 10 kg pacharo pave 10 kg ya oxygen, pavana 10 kg ya hydrogen. No. By mass, they exist differently. The rumor is that the rest of the universe, as sci-fi and everything and research, is that the most abundant element in the world is iron, because they say even in Jupiter there's iron, but on the Earth the most abundant is oxygen. Why? Because oxygen is in water. You've seen how the oceans. So you have oxygen. You have oxygen by mass. So oxygen is so abundant. Why? The oceans, because most of the universe is water. Then also sand is SO2, silicon dioxide. So you discover there's a lot of sand also in the world. If sand was money, guys, we would not be rich. So those are the things. So you find elements are distributed unequally in nature. Some are in very small quantities. Some are just in a lab. Some are in huge, huge quantities. And the beauty about life is that these things that are like oxygen, is very vital, but it's very free. Imagine if it was for sale. Very few people would believe in. So those are the things that you should also know, that elements are distributed very unequally in nature. In fact, 99% of the mass of the Earth's crust, seawater, and atmosphere is composed of only 10 elements. So there are tables there on your notes. You find them, the tables. So you will discover that even by mass, you find oxygen is almost 50% of that mass. Oxygen is almost 50%. Why? I've already explained why. Then there are also different masses. You have iron. Everywhere you see red soil, that's iron. So you must also know those things. So please, please, please try to understand that perspective where we say elements are distributed very unequally in nature. So now, the other point is just to say that of all the known elements, only two elements, not compounds, only two of all the known elements, only two are liquids at room temperature. Only two are liquids at room temperature. Please don't confuse with the compounds, because some of you will say, ngamish, because that's the only liquid you know. It's not. That water is a compound, but we're talking about elements. So only two elements are liquids at room temperature. What is room temperature? That range from 20 to 30, averagely 25 degrees. So now, because the room temperature has changed when you are solving, someone will tell you at a room temperature of 20, at a room temperature of 30, at a room temperature of 28. Room temperatures are a range from 20 to 30. But if someone asks you what is room temperature, you assume the average of 20 and 30, which is 25. So now what I'm trying to say is that two elements are liquids, and those are mercury and bromine. Mercury and bromine. So those two are liquids. Then 11 are gases. 11 elements are gases. So these are hydrogen, oxygen, nitrogen, fluorine, chlorine, and all the noble gases. And all the noble gases. Helen, you have a question? Helen, do you have a question? Lucy, Lucky.
Yes, sir. What makes iron to be the most abundant element?
Now it was a question. It's a tough question. Yeah, just because soil is mostly iron and the universe at large, because we're talking about the universe, not just the world. The earth, the most abundant, we already said, is oxygen. But we're saying in all these other continents, there's soil. So everywhere you see red soil, that is an abundance of iron. So meaning there's just a lot of iron in the world. That's why you find even the blast furnace uses a lot of energy. The more the abundance of something, the difficult in extracting it. So that is the aspect. So just know that everywhere, because there's so much soil in the world, and soil contains iron, that's why iron is abundant. That should be the reason.
Okay, thanks, sir.
All right. One of the things I want to emphasize also, before I forget, is that very few elements can be found in their pure state in nature. One of the ones that you can find is gold, the most valuable element, because it's very unreactive. I'm sure if you've seen the reactivity series, gold is even below hydrogen there, meaning it's not reactive. So you can find gold in its pure state, in a bit of pure state. You can also find silver in a bit of pure state. The rest of the elements are found in compounds. The rest of the elements are found in compounds. Meaning, like if we say even men and women, they marry. That's the reason you can say that almost everyone marries, but very few they stay at the acre. Because one, the my emotions, they've controlled themselves, they're not reactive. Remember, some of you are reactive. You definitely want to settle down, isn't it? So those are things you must know. So most of the elements are found in compounds. That's why industries are set so that you can purify them. That's why there's a copper mine. The copper mine, if copper was just in its pure state, ngabatola fe copper baanokwera. Remember, there's a mine. Why? Because they will react with acids, they will do what? They will mix with what? Why? Because it must be purified. Okay? So those are things. One of the other things I want to emphasize is have a periodic table, know about the symbols of elements. The symbols of elements. Those are the ones, because elements have different sources, so you find the symbols are not representative. Helen, is there a question? Pumolo, do you have a question? Huh? Pumolo, I'm getting you. Tamule umfika tatabat mwa Pumolo. Network problem. Huh? You ask me properly. Shidemi umfatata. So those are things. Maybe switch off the video and just remain the mic, and then ask again. Helen, why is your mic on? You want to say something? Okay, so now those are things. So now I just want to encourage you to go and look up the symbols of elements. Go and look them up from your periodic table. So a symbol is a representative of the element. In chemistry, ion. People will just write a symbol and say Fe. Then you are supposed to know, you as a chemist, you're supposed to know that this is ion. Cu, this is copper. Why Fe? Fe tamuli po ion ions like ama letters amuli ion tapali F. Why? Because those things are from different sources. It's also in your handout. You can go and go through. You will see that these things have different sources. That's why the names and the symbols were collected from those places where the name was. So that's the reason that we have. The next thing we're supposed to talk about is the periodic table. After some time, we'll have to talk about the periodic table of elements, because that's why we'll be finding our elements ourselves. So please make sure you have time to go and look at the periodic table. But what I want to emphasize are the same things that we've said. So one of the things you will know, don't go and waste your time swatting the periodic table. It won't come. No one will ask you to say what is number 99, 91 element. No. But we expect you to know how these elements, their trends, their groups, especially when you look at the periodic table, their trends and everything, how they should enter into the reactions. We are interested because this is chemistry, and the interest is chemical reactions. So we want to know how these things react. So please, please, please go through, try just to be prepared. I'll give, the next topic is periodicity. We'll look at the periodic table, and we'll also look at the compound. This thing should be covered in a very short space, but then we are learning online. So I'm supposed to be very careful as I disseminate my information to you guys. I don't want you to suffer. like to bombard you with a lot of the data, because we are supposed to be understanding. I'm expecting questions, guys, because we're remaining with, I think, 8 minutes, and I've explained too much, so that I clear you and we clear each other and we help one another. So those are things. So don't worry, isotopes, we'll talk about them. Don't worry about subatomic particles, we'll also talk about them. Don't worry about compounds, we'll also talk about them, how you get a compound. But you already have a head start, you did bonding. Bonding, the essence of the bonding was to produce a chemical product. So when there's bonding, then a product is expected, the compound is formed. So those are the expectations. And sometimes compound and compound react also. You already know all that aspect. Then the distribution of elements in the human body, we also have a table there, just to know which elements are important in our bodies. When the herbalist is lying to you, herbalist that's more than God, then you realize that there's no God. Like, God is not important to be in your human body. Shwa ni poison na ratio wa mayebs. Kama walumbula lim calcium, why should baba herbalist now should for the land up. So now, guys, I want you to ask me before we close. Any question? Namwekala sana zi. Mapalo, what's going on?
Trying to think of a question, sir.
Eh?
You're trying to think of a question.
Onishmomva fyonse muli bamawala mayo nami omva mayo okutila imwe namumva fyonse. Congrats. Who else has a question? So
Sir.
Stephen.
Yes, sir. What about plasma?
Plasma, that was a solid liquid gas. That's plasma. Plasma is something electronic, I think, made from quartz. In fact, it's made from these metalloids, plasma. But the people say it should also be identified as the fourth state of matter. But for us in chemistry, we're not in the electronics. To us, there will only be 3 states of matter. But someone in electronics will force you to say, identify plasma also as a state of matter. For us, it's something to debate. So that's how it is. Plasma, say, is semi-solid, and it must also be a state on its own. That's what they say. So to us, plasma has no raw. Yes, guys? Pumulo, you have a question. I said, if you try to switch off the video, hello, I shafed in become mic, the miss to amune for Tataba Pumulo. Kosimule Chusha phone. Yes, Pumulo. Yes, Pumulo. Eh, she didn't mean for that. So those are the aspects. You guys, you are seeming to me like you don't have questions. So the task is, let me just explain to you that I have actually put another handout on your Stud Master. I've put another handout on your Stud Master, a PDF, because I have discovered that you love PDFs. I don't even know if you go through them. So go and get that thing, go through the second handout, try to understand everything you can about the element. Remember that you are most interested in the symbols, because the biggest skill from you in the language of chemistry is how to write the chemical formula. The chemical formula, guys, ngatawishi befe chemical formula. Nishina skulu ya kukanga.